That is chapter 1, that is types of switches concept. Already concept I given. Continue with the classroom workbook. In the topic 1, I solved the problems based on the calculation of average switching power loss and energy loss. Yes. Then you go for topic 2 in the same chapter 1 classroom workbook, that in the workbook that given in topic 2, that is ideal characteristics of semiconductor switches or devices. Now based on this concept, we'll see some models of questions. The first question you see, what is given? Concentrate. But the first one it is given. Figure shows, this is problem number 1 in topic 2, ideal characteristics of semiconductor switches or devices. Figure shows 4 electronic switches, that is 1, 2, 3 and 4. Which of these switches can block voltage of either polarity, that is applied between terminals A and B when active device is in the off state? Means in the given figure, then which switch blocks both the polarity of supply? In detail about based on this the concept I given. Okay, tell me, in the given figures, then which switch blocks both the polarity? Both the polarity in the sense positive and negative. Both positive and negative polarity, negative supply. Okay, the first one is, what the first figure you tell me? It is given BJS. It is what this one? Yes, IGBT. IGBT with anti-parallel diode. IGBT with anti-parallel diode. This is first one. IGBT with the anti-parallel diode. Okay. This is first figure. Okay. Then what is the second one? This is also IGBT with a series diode. IGBT with a series diode. Yes, concentrate this. IGBT with a series diodes. Series diode. Sorry, this IGBT na. Yes, IGBT with a series diode. Or third one is given as a thyristor. A thyristor is given. Fourth one is, what is fourth one? Which device? What is the name of that device? Yes, a thyristor with anti-parallel diode na. A thyristor with anti-parallel diode is equivalent to, it is RCT, reverse conducting thyristor. A thyristor with anti-parallel diode. A thyristor with anti-parallel diode. This is RCT. Now, in these devices, which devices blocks both the polarity of supply, both positive and negative? We know this. This characteristics in detail already explained. For this device, if you draw the ideal characteristics, this is I, this is minus I, this is V, and this is minus V. For this also you draw the ideal characteristics. Then this is I, and this is minus I, this is V, minus V. Okay. What about this device? You draw the ideal characteristics. Then this is I, that is minus I, V, minus V. Okay. Then draw the ideal characteristics of this device also. This is I, this is minus I, V, minus V. Can you draw the characteristics, ideal characteristics for these devices? then we can understand. Then which device blocks both the polarity of supply? Then is IGBT na? In general, a transistor means in which quadrant it is operated? First quadrant. With anti-parallel diode, it allows which current? Reverse current. That means, is it blocking both the polarity of supply? No, it blocks only one polarity. Okay. Now, I told this IGBT is operated in which quadrant? First quadrant. Because of series diode, it blocks which voltage? Extra reverse voltage. Understood? Then thyristor then it allows forward current. It blocks both the polarity of supply. It blocks both the polarity of supply. Then what about this thyristor? Because of anti-parallel, this thyristor and diode, it allows in both the direction. But because of diode, if you apply positive supply, if the positive supply is given, I told in detail about this one. If the positive supply, thyristor is forward blocking mode, that's why it blocks only forward voltage. It cannot block reverse voltage. Tell. Now, which devices blocks both the polarity of supply? It blocking only one polarity. This is not the answer. And it blocking both the polarity. Yes, this blocks both the polarity of supply. Then this blocks both the polarity of supply. But it blocking only one polarity of supply. Then what is the answer? That is 2 and 3 blocks both the polarity of supply. In the given options, which is correct answer? Yes, option C is correct answer. Then what is the answer for this problem? Answer is option C is correct answer. Okay, that is 2 and 3 blocks both the polarity of supply. Understood? Okay, this one question based on this concept. See the second one, match switch arrangements on the top row to be steady state VI characteristics. On the lower row, the steady state operating points are shown by large black dots. Okay, match switch arrangements on top row to steady state VI characteristics. On the lower row, the steady state operating points are shown by large black dots. Okay, then match list 1 with list 2. Okay, here is the second question. This is the second one. Question number 2 in the topic 2. Okay. Yes. Tell me what it is given. Yes. Here devices are given and its characteristics are drawn. Then what is the matching for this one? First device is diode. Okay, A. Diode is given. Okay. Second one is B. Thyristor is given. Yes, thyristor is given. Third one is IGBT is given. This IGBT is given. Yes. D is IGBT with anti-parallel diode is given. Then which is the matching you tell? In this side, what it is given? First one. The characteristics are given like this. This is IS, VS. The second one is again the characteristics. This is IS, VS. Third one is this is IS, VS. The fourth one is this is IS, VS. Okay, and the characteristics are represented with large black dots. Okay, in the first one, what the dots given? Plus I plus VS. Second one, plus IS minus IS plus VS. Third one, minus VS plus VS plus IS. Fourth one, S minus VS plus IS. Tell. Diode na, that you know. Diode blocks which voltage? Reverse voltage. Allows which current? Forward current. Then which is the matching? A is matching with 4. Understood? Next, that is A is matching with 4. Second, thyristor. Thyristor blocks both the polarity, allows one direction, that I already given in the concept. Thyristor blocks both the polarity and allows in one direction. Then B is matching with third one. Next, this is IGBT. This is given like this, plus minus IGBT. IGBT means it always operates in which quadrant? First quadrant. You don't have any series diode and anti-parallel diode. Then C is matching with 1. C is matching with 1. Okay. Then what is the D? With anti-parallel diode means in first quadrant and allows in the reverse direction. Then D is matching with 2. Then A is 4. Which option is correct? You tell me. A is 4, B is 3, C is 1, D is 2. Then option C is correct. No. Then what is the answer for this one? Answer for this one is option C. Understood? Okay. That is like that you answer. Concentrate. All the characteristics are already given in the concept, that we are solving the problem. This model is important, already framed in GATE or IS, in other competitive point of view also. These models are important. Okay, understood? Just I'm matching that one. Okay. In the same topic, see the third question. An electronic switch S is required to block voltage of either polarity during its off state as shown in figure A. This switch is required to conduct in only in one direction. Its on state as shown in figure B. Which of the following are valid realization of switches? That means you want to realize the switches which blocks both the polarity and allows only in one direction. Understood? Then this is third question in this model, in this topic. Understood? Okay. Yes. In figure A, it is given that this is a switch arrangement. This is switch arrangement. This is plus minus, minus plus. This is actually it is a 1 dash. Then this is the switch arrangement during on state. During on state, this also 1 dash. Which of the following realizations are which allows only in one direction and blocks both the polarity? Okay, blocks the both the polarity. Okay. Now that means blocks both the polarity, allows in one direction. See the first one, what it is given? It is thyristor. First one is given as thyristor. That is, we know it blocks, thyristor blocks both the polarity. The characteristics we already seen. Allows one direction. It allows only in one direction. That you know. Understood? Then a transistor with anti-parallel diode. What the second one you tell me? A transistor with anti-parallel diode. A transistor with anti-parallel diode means blocks one polarity. Blocks one polarity. Blocks one polarity and allows both the direction. And allows both the direction. Both the direction. It's okay. See the third one. What it is given? A transistor with series diode blocks both the polarity. Blocks both the polarity and allows one direction. And allows one direction. Understood? All these characteristics I given. No need to draw once again. What is the fourth one? Yes, fourth one. That is a transistor with series diode and anti-parallel diode. Can you try this one? Characteristics for this one. It is given like this now. With a series diode, with anti-parallel diode. This is fourth one. Can you draw the characteristics for this one? This device. Try this. This is I, this is minus I, this is V, and this is minus V. Can you try this one? Because of anti-parallel diode, it allows both the direction. Correct? Yes. For example, if it is positive, negative, with this polarity, diode is under, this diode is under reverse bias condition. But even though it is a forward bias, but this positive voltage is blocked by which one? Yes, transistor blocks forward voltage. That's why it blocks. You can apply negative, positive. If you apply negative, positive, this will not block, but this diode will block. But even though this diode will block, with this polarity, this diode is on condition. Then this is under off condition. Okay. Now this diode is conducting like this. Even one device is conducting, it is blocking or conducting? It is conducting. That's why it cannot block the negative voltage. That's why it also blocks how many polarity? One polarity. But the question is framed. The device which blocks two polarities allows one direction. Blocks one polarity and allows both the direction. Blocks both the polarity allows one direction. Blocks both the polarity allows one direction. Then which is correct answer? 1 and 3. 1 and 3 means option C is correct. Answer C. Understood? Okay. But this arrangement blocks only one polarity, but allows in both the direction. Understood? See, one observation here. Any transistor, it may be BJT or MOSFET or IGBT, with a series diode, extra it blocks reverse voltage. Actually, it is first quadrant, extra reverse voltage. With anti-parallel diode, actually it is a first quadrant, extra it allows reverse current. A series diode and anti-parallel diode. A series diode and anti-parallel diode allows only reverse direction. Extra it reverse direction. Actually it is the first quadrant transistor. Then even though it consists of both the diodes, it allows only extra in reverse direction. Extra characteristics we are getting this one. Actually it is the first quadrant, extra we are getting in the reverse direction. Understood? This is the third one. You go with the fourth problem, fourth question in the same topic. What are the advantages of theory question? What are the advantages of switching power supplies over linear power supplies? Okay. The first statement is this is the fourth one. Concentrate on fourth one. Question number 4 is what are the advantages of switching power supplies over linear power supplies? The statements are given like this. The devices operate in linear active region. The devices operate as switches. Power losses are less. Select the correct answer using the codes given below. I told already, power electronic devices are more efficient because of these are operated as a switches. Operated as a switches means these are operated as in cutoff and saturation region. That's why these devices are operated as a switches. That second statement is correct. Because of switch operation only, that is more efficient. That is one advantage. And power losses are less. Power losses are also less for power supply, switching power supplies. Less switching power supplies are nothing but a power electronic circuits. Is more efficient because these are operated as a switches. And power losses also less. That's why second statement is correct. Third statement is also advantage. That is second and third is advantages means then what is the option? Option B is correct. Then what is the answer for this? Option B. Understood? Advantages. This asks for what is the advantage of switching power supplies. Okay. Because of you operated as a switches, that is one advantage. Once it is operated as a switches, power loss is less. That is also another advantage. That is the second and third statement is advantages. That's why option B is correct. Okay. These are the models of questions in topic 2. In the same chapter 1, topic 2. Understood? Now, go for topic 3 in the same chapter, that is types of switches concept. Calculation of average conduction losses in switches or devices. This comes under topic 3. Go for topic 3. Yes. This is topic 3. Calculation of average conduction losses. Calculation of average conduction losses, average conduction losses in switches or devices. In switches or devices. Devices are used as a switches. Okay. This is topic 3 in chapter 1. Okay. Go through with first question in topic 3, that is given classroom workbook. First question. Then what is the solution for this problem? Yes. A MOSFET is modeled as on-state resistance of 2 ohms and voltage drop of 1.5 volts. A current waveform as shown in figure is applied to the MOSFET. The average on-state power loss is dash. A MOSFET is modeled as an on-state resistance of 2 ohms and voltage drop of 1.5 volts. A current waveform as shown in figure is applied to MOSFET. The average on-state power loss is dash. Tell. Given that MOSFET is, this is MOSFET. Modeled as, MOSFET is modeled as on-state resistance of 2 ohms and voltage drop of how much it is given? 1.5 volts. 1.5 volts. Okay. Now, for this, a current waveform as shown in figure. This is the given current waveform. Okay. Is applied to the MOSFET. For this, if this current waveform is applied to the MOSFET, this is given as 2, 4, 6, T. This is 10 amperes. Okay. Then what is the average conduction losses? That is the question asked. Now, if this current waveform given is MOSFET is this one, yes, voltage drop of, this is 2 ohms, this is 1.5 volts. Then it is applied to, in the concept I explained. Okay. If the resistance and voltage drop is given, then how to calculate average power loss? Then average power loss is calculated like this. With respect to resistance, you take RMS value na, I RMS square into R on. With respect to voltage drop, you take average value. That means you want to find average power loss means you know what is the RMS value of this current waveform and what is the average value of this current waveform. Okay. Now for this current waveform, you want to calculate average and RMS currents. Okay. So many methods are there to calculate the average and RMS values. But whatever may be the method, the best method of solving average and RMS value is integration method. But for this type of waveform, the waveform is given like this, it is a pulse waveform. If the waveform is given like this, for this type of pulse waveform, okay, this is the pulse waveform. This is 2, 4, 6 NTs in seconds. This is, or otherwise, first I want to give one standard formula. Okay, for this type of current waveform or voltage waveform, that this is amplitude. Then how to calculate? If it is I, then how to calculate I average? I average equal to A into T on by T. I RMS equal to A into amplitude into square root of on time by total time period. You remember as this as a note. Okay, this is T on. This total is T. Okay, this is T off. Then average value. How to get average value? Amplitude into T on by T. How to get RMS value? Amplitude into square root of T on by T. Then this problem, this formula, we can apply for this waveform. Okay, for this type of wave, we can apply these formulas either pulse waveforms or rectangular waveforms. Then what is the average current? I average. What is the amplitude? It is 10 amperes, 10 into. What is the on time? 2. What is the total time period? 4. Then how much you get? 5 amperes. Okay. Now, what is RMS? What is RMS? Amplitude is how much? 10. 10 into square root of 2 by 4. That is 10 by root 2 amperes. This is one way to calculate average and RMS values. If you are not remembering these formulas means, the best method of solving average and RMS values is integration method. The best method is integration method. Go through with or I am explaining like this also. You solve like this also. Method 2. Another method to calculate average and RMS values. Now what is the average current? Average current equal. What is the time period of this waveform? You tell me. What is the time period of this waveform? How to define time period? The starting waveform again repeated at a time of, that is nothing but a time period. Whatever the starting wave shape is there, then again at what time it is repeated? At 4 seconds again it is repeated. That's why you take time period is 4. Understood? The time period is 4 seconds. You take again, that is time period is 4 seconds. But if it is not repeated, it is a non-periodic waveform, then total time is taken as a time period. But it is repeated now. Time period is 4. That is 1 by 4 integral 0 to 2. It is a constant current now. It is a constant current 10 dt. 10 dt. Then what do you get? 10 by 4. Integration of constant is t 0 to 2. Then 10 by 4. 5 into. That is 10 by 4 now. 10 by 4 means that is how much? 2.5 into 2 minus 0. Then how much you get? 5 amperes. Then how to calculate RMS value? IRMS equal to. Then RMS means 1 by 4 integral 0 to 2. RMS means square. Na? First square this one. 10 square dt. Whole to the power of 1 by 2. That fundamentals, average and RMS. Okay, that we are doing. Then what you get? 10 by 2. 10 by 2 integral 0 to 2 dt whole to the power of 1 by 2. Integrate and substitute the limits. Then what you get? 2 minus 0 whole to the power of 1 by 2. Then what you get? 10 by root 2 amperes. This is average value and RMS value. Once you know the average current and RMS current, then what is the power loss? You want to calculate average power loss now? Tell me. What is the average power loss? IRMS square into. What is the RMS current we are getting? 10 by root 2 whole square. On state resistance 2 ohms. VD 1.5. What is I average? 5 amperes. Yes, 100 plus. This is how much? 7.5. Then how much you get? 107.5 watts. This is average power loss. Very simple. For a given current waveform, calculate average and RMS values, substitute here, then you get the average power loss. That is 107.5 watts. Understood? Clear? Then go for second question based on this problem, based on this topic only. See the second question. This is okay. Question number 2 in topic 3. Okay. An IGBT is modeled as on-state resistance of 8 milliohms and voltage drop of 1.1 volts. A current waveform as shown in figure is applied to IGBT. The average power loss is dash. Okay. Given that IGBT is modeled as on-state resistance of 8 milliohms and voltage drop of 1.1 volt. This is IGBT. This IGBT is modeled as on-state resistance of 8 milliohms and voltage drop of 1.1 volt. This is modeling it is given. This is the current waveform. This current waveform is applied to IGBT. Then the average power loss equal to dash. This is pi, 2 pi, 3 pi, omega t. This is given how much? 100 amperes. That means for this we are applying the voltage. This is 8 milliohms, 1.1 volt. This current is applied here. If any semiconductor is represented with or modeled with both resistance and voltage, then what is the formula for average power loss, you tell me? IRMS square into Rom plus VD into I average. That means you want to calculate average power loss means you want to calculate RMS and average value of this waveform. Then directly also you can write. Later on I will give the proof also in the discussion of rectifiers for this one. But here I am writing directly. It is a half wave rectifier output na. So sinusoidal nature. Okay, half wave rectifier output na. For a half wave rectifier output, tell me what is the average current? This is half wave rectifier output waveform. For a half wave rectifier output waveform, average voltage is Vm by pi na. Just like I want to write Im by pi. Im by pi. Then what is Im here? 100. 100 by pi amperes. What is the RMS current? That is Im by 2. Im by 2. Just like Vm by 2. If it is voltage, Vm by 2. But here current na, that's why I am writing Im by 2. What is Im here? 100. 100 by 2. That is 50 amperes. Then what is the average power loss? Then average power loss equal to. Then the average power loss equal to, that is IRMS square. That is IRMS is 50 square into 50 square. What is the on-state resistance? 8 milliohms. 8 into 10 to the power of minus 3. VD is how much? 1.1 volt. VD into, what is I average? I average is how much? 100 by pi. Then what is the average power loss we can get? This is 2500 into 8 into 10 to the power of minus 3 plus 1.1 into 100 by, that you simplify this, what you get? 22 by 7. Then average power loss equal to, this is simplify, what you get? 2.5 into 8. This is how much you get? 20 plus. This how much you can get? 1.1. This is 20 times. This is 700 by 20. Then how much you get? Average power loss equal to 20 plus 35. How many watts? 55 watts. This is okay. This is question number 2 in topic 3. See, concept is very simple. For this type of model, whatever the waveform is given, for given waveform, you calculate average and RMS values, substitute in the formula, then you get the answer. If it is represented both resistance and voltage. If it is represented only with resistance, you calculate only RMS value. If it is represented with only voltage drop, we calculate only average value, multiply that, then we get the answers. Okay, it's very simple. Go for in the topic 3, the question number 3. Is okay? Okay. Topic 3, that is question number 3. Okay. Then SCR is modeled as, what is the question number 3 in topic 3? SCR is modeled as on-state resistance of 1 ohm and voltage drop of 0.5 volts. A current I of t equal to 3 plus 4 root 2 sin omega t plus 30 is applied to SCR. The average conduction losses is dash. Okay. Then that we will see. Given is SCR is modeled as on-state resistance of 1 ohm. SCR is modeled as on-state resistance of, SCR is modeled as on-state resistance of 1 ohm. On-state resistance of 1 ohm. And voltage drop of 0.5 volts. And voltage drop of 0.5 volts. On-state resistance 1 ohm and voltage drop of 0.5 volts. A current I equal to 3 plus 4 root 2 sin omega t plus 30 is applied to SCR. The average conduction losses equal to. Then what are the average conduction losses? Average conduction losses or average conduction power loss. It is represented with both resistance and voltage drop now. If it is represented with both resistance and voltage drop means IRMS square into R on plus VD into I average. Okay. Now for this current you want to calculate average and RMS value, then you substitute here, then you get the answer. It's very simple. Okay. Now tell me, what is the RMS current and average of this current? Okay. But to solve this, you remember as a note. It may be voltage or current. It may be voltage or current. If I equal to A naught plus A1 sin omega t plus theta plus A2 sin 2 omega t plus A3 cos 3 omega t plus theta plus and so on. For this type of current or voltage signal is given, voltage equation is given. Then how to calculate average current? To calculate average current, we can do like this: 1 by 2 pi integral 0 to 2 pi I d omega t. But every time doing integration and substituting the limits is lengthy procedure. That's directly remember for this type of current equation, average equal to A naught. Constant indicate the average. Then what is the RMS current? What is IRMS? Then 1 by 2 pi integral 0 to 2 pi I square d omega t whole to the power of 1 by 2. But every time doing integration and substituting limits is lengthy procedure, then directly remember like this. For this type of current equation, RMS is A naught square plus A1 by root 2 whole square plus A2 by root 2 whole square plus A3 by root 2 whole square plus and so on. This you remember as a note. Okay, this formula is very important. This note is very important. I am not giving derivation, that you concentrate. It is very important to answer this type of questions. Okay. Now this formula I am applying for this one. What is I equal to 3 plus 4 root 2 sin omega t plus 30. It is given like this. No? Then what is the average current? Constant indicates average current, 3 amperes directly. No need again substitute limits, integration, all this. Then what is the RMS current, you tell me? RMS equal to square root of 3 square plus then 4 root 2 by root 2 whole square. Then how much you get? 5 amperes. A naught square plus A1 by root 2 whole square, no? 5 amperes. Then what is the average power loss? IRMS square into R on. What is the RMS value? 5 square into on state resistance 1 ohm. VD into I average 0.5 into what is the average current? 3. This is 25 plus 1.5. Then how much you get? 26.5 amps. Over. Understood? That is third question in this topic. Then last one we will see based on this topic 3. In the following circuit, calculate average conduction losses in a device. Okay, this is understood. So this first. This note you remember. Throughout in the power electronic circuit analysis also we can use this formula. Note remember. Whenever I asked during solving the problem, you ready to write that formula. Okay, that is I average, that is IRMS currents. Concentrate. Then calculate average conduction losses in a device. This is the device given like this. This IDC equal to 10 ampere. The characteristics of both actually both transistor and diode is given. This is BJT characteristics. Yes, this is I and this is V. This is I, this is V. Then this is characteristics is delta V by delta I is equal to 2 volts per ampere. Okay, and this one is diode characteristics. This is diode characteristics is given that this is I, this delta V by delta I equal to how much? 2 volts per ampere. This is V. Then based on this characteristics, can you model this one? Resistance of 2 ohms and voltage drop of how much? This is given as 1.5 volts. This BJT model. Can you model this one? Resistance of 2 ohms and voltage drop of how much? This is given as 0.5 volts. Yes, calculate the conduction losses in a device. Calculate the conduction losses in a device, that is given. Okay, means the device which conducts, in the device only conduction losses are takes place. Tell me, in which device losses are exist? The device which conducting, based on the current direction, diode is conducting with this current direction. This is the 10 amperes current is flowing now. If this current means this BJT cannot allow in the reverse direction, that's which is conducting diode. If the diode is conducting, you want to calculate power loss in a diode. It is not mentioned. Calculate BJT diode like that. It is not mentioned. In this figure, calculate the conduction losses in a device. Then which device is conducting? First you want to identify. That means based on current direction, diode is conducting. Hence, calculate power loss in a diode. Okay, diode is conducting. Calculate power loss in a diode. Given this a constant DC current, a constant DC current 10 ampere. For constant DC, average is how much? 10 ampere. RMS is also 10 ampere. Average is 10 amperes. RMS is also 10 amperes. If average is 10 amperes and RMS is 10 amperes means, then you want to calculate power loss in a diode. You want to calculate power loss in a diode means P average is equal to I RMS square into R on plus VD into I average. What is I RMS? That is 10 square. What is the on state resistance? 2 ohms. What is VD? 0.5. What is I average? 10. How much you get? 200. This is 205 watts. Clear? That means if it is not mentioned which device you want to calculate. But based on the figure, current direction is like this now. Current direction is like this means which device is conducting? Diode is conducting. Diode is conducting means you want to calculate the power loss in a diode. Then diode is represented with equivalent both resistance and voltage drop, it is modal. If the both resistance and voltage drop is modal, then average power loss equal to I RMS square into R on plus VD into I average. It is a constant current. If a constant, if it is given like this, constant 10 ampere, what is the average value? 10. RMS value is also 10. That's why for a constant DC, average and RMS values are same. If average and RMS values are same, then what is the form factor? Unity. For a constant DC, form factor is unity. Understood? Okay, this about different topics I covered in chapter 1. With this, the concept of chapter 1 is already completed. That is based on types of switches, and I covered 3 topics, 3 models of questions. Topic 1, topic 2, topic 3. Okay, in topic 1 I discussed the classroom workbook problem. Topic 2 also I discussed, and topic 3 also I covered the models. With this knowledge, based on this types of switch concept, you answer any question. Understood? Clear? Okay, please concentrate. Okay, with this Chapter 1 classroom workbook is completed. Understood. Concept is over. Classroom workbook questions also in 3 topics is complete.